Hi there, you're right, it's Tommy Allen here, and today I'm just going through with you the second part of my early reflection and occlusion system built in Unreal Engine and C++ code. So if you haven't seen the other video, that it explains how we get the data and the concept behind how the occlusion works and what we're actually picking up. And here is, now I'm telling you how I route it all. So first of all, we have made this code called Tap Delay Manager. And in this Tap Delay Manager, we have 5 submixes that we can attach to it. And on these, we have our tap delay effects. Okay? So what's going to happen is as we play the game, our tap delays are going to be updated in here. I am going to show you that live now, okay? Just to give you an example of how this is working. So, as I shoot the gun, we can see it is happily updating. Okay, so they're all updating. So because we only have, for example, so in our shooter player character, in our acoustic player balls, they're all talking to each other because we only have a 90-degree angle separation if we turn these down to 45. Okay, so here we've got 14 elements for our reflections. If we turn these back up, compile, okay. Now, on our first shot, it all updates, and now we've got 42. Okay, so now we've got a lot more rays, and as we walk about, okay. Okay, so that's basically what's happening. So the problem that I ended up facing is it'd be, awesome if I could have a separate submix and a separate tap delay for every single actor in the game. But in this game, there's there's a lot of enemies, so every single one would need its own special tap delay, which would be chaos to create, okay? Because, well, there's lots of audio in games, or lots of different actors, and it'd be too many to make. So I made the tap delay manager, okay? And this tap delay manager, 5 submixes with tap delays attached, and then on your actor, you can then put the custom audio component, and it's going to route all the audio that you hear through this custom audio component, and it's going to set these target submixes. Okay, so to prove that this is working on the tap delay 2, I've also added, or on the submix tap delay 2, I've added a ridiculous reverb effect to make it really clear. So now this is added on, this component. The audio from the gun blueprint is now being routed into here. So this works for C++ code. So in my I made this gun in code as well. We've actually got the sound. Oh. Yeah. So these sounds from here are being played through. It works through blueprints as well. And when it's just attached to an actor component. So it works pretty good. And it works when multiple are playing. So the reason why I did this, instead of having, so say you might have loads of different sounds running off the same component, you want them to run through the same submix, because it's kind of pointless having them all have the same calculations be done for something in the same position. Okay, and usually there's lots of different audio things starting and finishing. So the mathematics I use for the tap delay is, I'll try and pull it up in here. In the where are you? So tap delay, so we got distance and gain. So that's just the how far away the object is, and that'll be the gain. But then I've also calculated the angle of reflection of where the two angles would meet at the wall. Okay, and then I'm kind of taking that off. This is currently linear. You could kind of change it, but it sounds all right. And then the pan in degrees, okay, is actually, so the way the pan works, it's actually taking this line here. So the pan should never really change, okay, as we move around, okay, because it's kind of fixed to our head. So it's using them instead. Yeah, and so so the time is calculated from the distance, the gain is using the distance and the pan, and yeah, that's how it is. What we have, if there is no blocking here, so this shouldn't be false here. If it's being blocked, the tap delay goes to -96. Okay, so it's kind of almost just ignored. Okay, so that's just a little quick maths bit, and now I'm going to talk about the tap delay manager. So as you can see, it's coming up here. So in our source component, in our source ABDCD, or source ABCD, we have a priority value. So on this priority, I've turned it up to 1.5, and if I go to my, if I press play, okay, my player gun here has 1. So instead of having a tap delay for every single source and a submix for every single source, it routes the audio to the highest priority. So if you've got 10 actors, it's going to take the top 5 high priority actors and use them to drive the tap delay. So as you can see here, every time this turns on, it attempts to change the tap delay. So let me just pull up tap delay 2. There we go, that sounds nice. Where are you? Content. So I'm going to move this to the side so you can see. As we move around, the tap delay is going to change. But it now turns off. So having this whole thing used for this tap delay is a bit silly because it's a whole actor for one of our sources. When we fire our gun, you see that all the tap delays immediately change. So it goes on, and our tap delays start to change. So because this is a higher priority, this is going to take over from what our gun is playing. Okay? Okay, so you saw that quick little change. And then what this also will do is it's going to drive tap delay 3 instead. So it's going to move the priority and take them down the tap delays and reroute the audio signal. So when this plays, it should go to tap delay 2. Okay, when the gun plays and this doesn't play, it'll go to tap delay 2. Okay, because there's no actors with the priority and nothing's playing. There's only one actor playing, so it'll all be routed to 2. Now, if they're both playing, so I'm shooting and the little camera beep from this ball is playing, because this is highest priority, it'll drive tap delay 2 and be routed to submix 2, and then the gun will be routed to tap delay 3 through submix 3. And this is the best way I can think of is actually driving them. In the code, I only update the tap delays every 0.3 seconds, okay, rather than every tick, to kind of give a bit of an ease on the system, but also so it didn't, to try and mitigate a lot of the pops and clicks. So when I start running into the game, okay, remember I've changed all the settings, so it's not going to sound amazing right now because I've changed all the distances and things. It takes a bit of tuning to get right with the radiuses, But when there's more than 5 sounds, or when there's 5 sounds being played, then, or when there's when there's 5 being played, then this will finally get used. Okay, so let's see that in action. Actually, we'll use tap delay 4 because we got a bad guy here. So it's only got array of 14 when it should have array of 42. Let's get a bad guy in. He starts shooting us. Okay. So as soon as there was that extra click, there was 4 sources being played at the same time inside the radius, then it's going to utilize the 5th tap delay using the priority system. Okay, because you saw it just jump. So that was the kind of way around. For that whole thing, we had a kind of reverb, a ridiculous reverb turned on. So let's just turn that bad boy off. Where are we? Submix 2, turn this off. Okay, save. So yeah, so that was kind of the solution to kind of make it all work round and have submix being sent. So when you're also in the highest priority, the submix sends from 0 to 1, as well as the tap delay data of that object being updated as well. So let's have just a quick listen and how it sounds. Okay, so I'll put this to 1000, and I'll put this to 300. I like it at 300. Compile. And on this, I'm going to actually, let's just turn the audio off on here for a second. Let me clear this, and so you can actually really hear, okay, what's going on. So you can hear the reflection from the far left on there. Another one on the far left. And then it changes, you can hear the kind of outdoorsiness coming off on the right there. Okay, if we come into like a small space. And as we move around, we're kind of getting those frequency discrepancies because of the really close tap delays, those really quick giving us kind of frequency differences. Okay, so let me just turn back on the, I like that camera shutter sound. Camera shutter, we'll turn on the music. And yeah, let's hear it all at once. So I'm actually going to turn off the debug because they're really, really annoying. So we'll turn off the debug lines. Okay, there's the occlusion. I'm going to push this ball a bit further out. Ah, go away! Okay, so there's a couple of pops, there's a couple of things that need tuning, maybe the updating time, but that's as kind of far as I got with kind of making my own occlusion and early reflection system in code. The kind of other improvements, because what we actually do, we actually pick up the physical materials and the lines actually go all the way through, so I want to build a bit of a transmission system for it actually going through objects, and kind of find that kind of sweet point where the tap delays, you're not getting those little tipply taps and things like the little crack and popples, or the best maybe to interpolate the actual tap delay function slightly over time, so there's not these massive jumps. Okay, so that's as far as I've got with it so far. Hope you enjoyed it. I think I tried to explain everything. It was well long. There's so much code going on, but it's quite cool. So again, I tried to make it so you could just kind of drag and drop. So the audio design guy can do his audio design stuff, like putting it on the blueprints, and all you need to do is then drag and drop the source ABDC and the custom audio component. Okay, so that was it. It's quite long. I'm trying to explain my code, but that was just a kind of quick, brief explanation of what I tried to do. So hope that was useful, and I will see you later.